let's take a moment and zero in on the vagus and learn the anatomy of the vagus this semester. General anatomy of the vagus, those parts of the vagus at least that are important to the speech language pathologist. There's a lot more of the vagus that deals with other parts of the body that don't concern us. We're not going to learn those. So let's start with what we're looking at here. So up here top, you have the medulla. So remember that's part of the brainstem. Midbrain, pons, medulla. And then down here, this box represents the velum, and it represents the pharynx. Maybe I'll go ahead and draw a little velum here just to remind you. Velum and the pharynx. And then down here is the larynx. And you have the cricothyroids out here. And remember that within there, within the larynx, you have all the intrinsic muscles of the larynx as well, all the ad and abductors, in addition to the cricothyroid, which is on the anterior of the larynx. So now we're in a basic position to start talking about how the vagus innervates these structures. The vagus connects to the central nervous system at the medulla. So if we're talking about motor function, then you have your motor plans that are sent down to the medulla by the upper motor neurons that are then sent out along the vagus. So this is the main branch of the vagus. And the first point at which the main branch splits is known as the pharyngeal plexus. And the pharyngeal plexus is that part of the vagus that innervates the velum and the pharynx motorically. So it sends motor plans to the velum and the pharynx. And once again, this is a paired nerve. So for all of this stuff, you have a right and a left. And if we continue inferiorly on the main branch of the vagus, we get to the second place it splits. This split is referred to as the superior laryngeal nerve. So if you follow the superior laryngeal nerve, you're going to get to the point where the superior laryngeal nerve, or the SLN, itself is going to split. And it splits into the intrinsic and extrinsic branches of the SLN. The intrinsic branch of the SLN, right here and right here, this is an afferent portion of the vagus that is going to send sensory information from the vocal folds up the vagus to the medulla to be transmitted up to parietal lobe for processing, so that you can understand if you have something, if you have mucus on your vocal folds, or if you have some food on your vocal folds that has fallen into your airway. That's the intrinsic branch of the SLN. The extrinsic branch of the SLN transmits motor plans to the cricothyroid muscle. And remember that the cricothyroid muscle is that muscle that pulls the thyroid cartilage forward, tensing the vocal folds. And if we come back up to the main branch and follow it down south inferiorly, eventually it's going to go down into the upper part of your chest near your heart. And you're going to have on your right, you're going to have your subclavian artery. And on your left, you're going to have your aorta. And the main branch of the vagus at this point is going to turn. And this is called the recurrent laryngeal nerve. It is going to recur back into the neck. So that's the recurrent laryngeal nerve, or the RLN. The RLN innervates all the intrinsic muscles of the larynx that aren't the cricothyroid. So all the other muscles, so all the adductors and abductors. So why is it important that you learn all this stuff? Because let's say this individual is having heart surgery and the doc nicks the left recurrent laryngeal nerve. That will generate a left vocal fold that has paralyzed add and abductor muscles. So you're going to have a paralyzed left vocal fold. You're going to have to provide therapy for that paralyzed left vocal fold. Let's say you have a lesion right here. So something's wrong with the left extrinsic branch of the left superior laryngeal nerve. Then this individual, they're not going to be able to shift the pitch in their voice as much. So they're going to be more monotone. So they're probably going to be coming to see you for voice therapy so that they can have a normal prosody. If a person has a lesion up here on the pharyngeal plexus, then the velum is not going to be able to move appropriately. So they're going to have resonance problems. So they're going to be coming to see you. The pharynx isn't going to be able to move. So they're probably having swallowing problems. So they're going to be coming to see you. But more than likely, what you'll see is people are going to have strokes at the brainstem, and it's going to knock out an entire side of the vagus. So they're going to have a weakened velum, weakened one side of the velum. They're going to have a weakened one side of the pharynx. So resonance, swallowing. They're going to not feel food when it gets into their airway on that affected side. So they're going to be more likely to get aspiration pneumonia. They're going to have a more monotone voice because cricothyroid on the affected side is not getting appropriate motor signal. And they're going to have a very aphonic or dysphonic voice because they're going to have a paralyzed vocal fold. And on top of this, when someone comes in with any of these problems, you have to be able to look at them and understand, is this a problem with the vagus? And based on what you're seeing, you have to be able to isolate that problem to a particular side of the vagus, right or left, and a particular branch of the vagus. And then you have to know what therapy to give based on what you see.